Hi everyone, I welcome you all to the sixth video of this series where I am showing you how you can find the range for any given functions that you can deal with in the ES level syllabus. So far, we have looked into the straight line functions, quadratic functions, and square root functions. And just a quick addition, for the square root graphs in the last video, I did not write this point over there that you also need y-intercept. But then, as we encountered a problem over here in the second question, that without the y-intercept the graph that we had drawn was not really perfect, and because of that I have just added this line that in the square root graphs it's better if you find the y-intercept, so that even after doing the transformation you are aware about where exactly your graph is going to cut your y-axis. So I hope that is clear, and now we are going to utilize the same kind of concept, that how we can quickly draw the graphs for the given function, this time with the cubic functions, and based on that, whatever domain that we decide, how we can identify the range. So yes, let's get started. So as you can see on my screen currently, there are three things that you must know about a cubic function to sketch it very quickly. First thing is the shape of the cubic graphs. You already know that the straight line looks like this, quadratic looks like this, square roots look like this, cubic look something like this. Okay, and this kind of a shape, for you to understand it in a better way, on the Desmos I've already plotted this. And for a negative x cube, it's just the opposite of this. It's going to come down like this in the same kind of fashion. See, it comes from the top, and at 0 it comes like this. So that is what you should be aware about, the basic shape of the cubic graphs. Okay, not the entire, because this is not true every time, because the graph may look something like this. Okay, maybe something like this. Oops, maybe the other side, right? So this kind of things are also possible, but this is the general shape of an x cube. Okay, the important thing is that the graph is going to come down like this if the coefficient of x cube is negative, and the graph is going to rise up something like this approximately, you can say, when the coefficient of x cube is going to be positive. Okay, so that is the first thing that you should be aware about. The graph will come up if the coefficient of x cube is positive. It will go down if the coefficient of x cube is negative. The second thing you should be aware about is the x-intercepts. Okay, there could be only one x-intercept, as you can see in this case it is a. There could be two x-intercepts, in this case it is a and b. There could be three x-intercepts, that could be a, b, c. In all the cases, the graphs may look something different. Of course, depending on if there is a negative sign outside. But right now, I am not showing that negative sign. Without that only, I am going to show you how the graph looks like. If there is a negative sign, of course, you know that the graph needs to be flipped. That's it. So let's say if you are having only one root. In that case, how the graph looks like. Wherever the A is present, let's say A is present over here, the graph is going to look like this. The graph is going to look something like this. Okay, of course you need to know what is your y-intercept also, but yeah, approximately that is how it's going to look like. It can keep on going forward and upwards, like the downwards and upwards. In this case, on the when a and b are the part of your roots or the x-intercepts, let's say a is on the left side, b is on the right side. Now because b is a repeated factor, as you can see, so wherever there is a repeated factor, what you do, the graph is not going to cut the x-axis, it's going to reflect right from there. Okay, so let's say the graph is increasing. So first time it's going to intersect at the A, that is going to come up like this. And of course, whatever is the y-intercept, you must know about the y-intercept. And then it's going to come down and then reflect over here and then go up like this. Okay. In the third cases, as everything else is like in all the roots are different from each other. Let's say A is over here, B is over here, C is over here. In that case, remember that there is no reflections like this. The graph will go simply like this, this and this. Again, keeping into mind where the y-intercept is going to be. Okay. But yeah, I'll talk about all these three types of functions as a part of our example so that you are having a better idea about this. But yeah, the important thing is that x-intercepts are very much important for the cubic graphs. And similarly, the y-intercepts are very important as well. Remember that in your AS level, specifically the Cambridge syllabus, just like the square root graphs, cubic graphs are rarely asked. But you should be aware about these fundamentals, and that is exactly what we are going to clear. So to create a question, let me write find the range for f of x is equals to, let's say, x minus 1, x minus 2, x plus 1. Okay, and the domain over here can be a little bit tricky, so I'll just write my domain at the end so that I am not confusing you guys, because in the examination they're going to give you a domain so that it's becoming very easier for you to find out the range. Okay, sometimes it can be complicated, and that is exactly what I'm going to show you right now, that why it can be complicated. Okay, so let's get started with the graphical aspect. What are the three things we need to know? First of all, I'll just write that for, so that I can write the domain later on. First of all, what is the coefficient of x cube? Is it plus or minus? If I open the brackets, of course I'll have a positive x cube coefficient. So my graph is going to start going upwards, and then it's going to look like this, because of course there are three different factors. So there are three different roots: plus 1, plus 2, and minus 1. And that is what are the x-intercepts. And the y-intercept is basically when x is equal to 0. So if x is equal to 0, this goes to 0. You just need to multiply this with this. Minus 1 into minus 2 is plus 2. And then plus 2 into plus 1 is plus 2 only. So 2 becomes your y-intercept. So let me sketch this graph. So I am having minus 1, 1 and 2. Minus 1, 1 and 2. The y-intercept was 2. And now to sketch the graph, because the graph is having a positive x cube coefficient, it will go upwards like this, right? And the x-intercept is, y-intercept is 2. So it may look something like this, going upwards and then curling somewhere over here like this, and in between that like this. Now, if you can see, we exactly don't know from where to curl, right? We know that in between minus 1 and 1, somewhere between that I have to curl. And over here, in between 1 and 2, somewhere in between that I have to curl. I don't even know how much in the y-axis I need to go up and down. And because there are this kind of uncertainties involved, and you should not know about it directly without using differentiation. Okay, you are aware about that in your AS level syllabus there is a concept of dy dx, that once you equate it to 0, okay, once you find its derivative, equate it to 0, after that you are going to find that at which two values of the x you are going to have this stationary points. Once you're having the stationary points, you can find its respective y values by putting the x values in this original function, x stationary value in the original function. So I hope this has given you an idea that that is the reason why it becomes complicated. That, let's say for example, if I say that the domain is in between 0 to, let's say, some higher value, so the region of interest is this. Now how would you tell the range if you don't know how to find this minimum point? So of course in the syllabus of AS level this is not covered. So unless and until you don't know with respect to dy dx, you know the x stationary point, then you put that x stationary point in this equation to find the respective y stationary point, you will never know this particular value of y. So of course if this kind of graphs is asked and the range is asked in the next question, in that case you will see this kind of derivatives and the finding of the stationary and everything in the previous parts. Okay, and that was the reason why I was saying that it's a bit complicated to find the range, and that's why I was a bit hesitant earlier to write the domain. But now Let's say I'm writing your domain somewhere maybe to the left value of -1. Let's say I'm choosing -3, and on the right side maybe I'm choosing 3. So in between -3 and 3, if I choose like this, -3 is included, +3 is excluded from the domain. So in that case, if I use my CAIE and substitute x is equal to -3, let's see what I get. -3 -1 multiplied with -3 -2 multiplied with -3 plus 1. The answer comes out to be -40. So you can say that, if I can just say, so I can extend the graph a little bit, because of course the graph can keep on going downwards. And over here also, let's say somewhere over here, okay? So this is minus, what was the answer? -40. And when I replace my x from -3 to 3, let's see what I get. So in my CAIE, what I'm getting is 8. So of course this value is 8. And my graph is going to lie in this region. So of course the graph may not be 100% accurate because we don't know where the turning points are, but the overall shape is correct. And in this case, what is the range? It's going to go in between -40 to 8. -40 is your minimum value and +8 is your maximum value. So in this case, your range will be -40 to 8. Function is in between. You are having the less than sign. -40 will be part of the range because -3 was part of the domain. 8 will not be part of the range because 3 was not part of the domain. So now we can go ahead and check this on our Desmos. X minus 1, x minus 2, x plus 1. And the domain. Of course, now you can see the graph is not 100% accurate like what we had drawn, but the overall shape is correct. You can see, right? Overall shape is correct. That is what is required for the cubic graphs. So from -3 to 3. So the maximum value that it can go to, if I can zoom in, is 8, as you can see. And the minimum value should be -40, if I can show. Yeah, -40. So all the outputs in between -40 and 8 becomes your final answer, like what we have written over here. So yes, this is indeed correct. So yes, while you are practicing the cubic graphs, you might get a bit incorrect answers if you are choosing some values in the domain such that maybe this becomes the minimum value or this becomes the maximum value. Remember, you can't find the minimum and maximum for the cubic in your AS level, specifically Cambridge syllabus, without doing the derivatives. Okay, and if these kind of things are there in the previous part, you must have already done this kind of calculations. Now let's take a look into the next question. Let's say find the range for f of x is equals to, let's say this time, minus x minus 1 and x minus 2 squares. So first let me draw the graph. So if I draw the graph over here, my x-intercepts are +1 and +2. My y-intercept will be, of course this value is squared, -2 square is 4. 4 times -1 is -4. -4 into this -1 is +4. So +4 is my y-intercept. Okay. Now because x minus 2 is the repeated factor, at 2 I will either have this kind of a shape or this kind of a shape. It is not going to pass through the 2. From 2 it's not going to pass, but from 2 it is going to be reflected something like this, just like what we had seen while I was explaining you this part at the beginning of this video. And then because the coefficient of x cube, once you will open this brackets, will be negative, This time your graph is going to decrease, not increase, and this is the kind of overall shape approximately you will be expecting to get. So let's see overall how this may look like. So the graph is coming like this. At 4 there is intercept, and then it's going to come like this, and then it's going to reflect because 2 was a repeated root or a repeated factor. Okay, this is how the graph is going to look like. So now let's keep the domain, maybe let's say from 0 to 2. Yeah, let's keep 0 to 2. For that, I know that this is the minimum value that we can get. But how do I find this minimum value? I'll just use the Desmos to get those values. Just so that you know that if in the previous part you already know what is the x and y coordinate over here, you can of course solve the question like that. But anyways, let me just say that the domain is in between 0 to 2. Okay, that is the domain. So the region of interest is from here till here, because 0 to 2 lies over here. The respective outputs have been highlighted for you. So of course, what is the minimum value the function is able to give you in this region? This is the minimum point, and this is the maximum point, 4. So in between the 4 and whatever is the minimum value, you will see your range that is going to exist. Now how would you find the minimum? Of course, in the question you will have to do the derivative, equate it to 0, get the respective x value, and put that x value back into this equation to find the respective y value. But right now, let's just suppose that that kind of thing we are not doing x, and let me just write x minus 1, x minus 2, the whole square, and there is a negative sign outside. So as I told you, this is how the graph is looking like. And this minimum point is 1.333 comma minus 0.148. 1.33 minus 0.148. Okay, so I'll just write that this is taken from Desmos. Value taken from Desmos. Alright, so now what is going to be the final range for this? In the selected region, I can say that the minimum value is minus 0.148 less than f of x less than 4. Okay, so 4 is the maximum value, is minus 0.148 is the minimum value, and in between that all the other values will lie that I have highlighted in the yellow region. Okay, and is minus 0.148 to be included as a part of the range? Yes. Why? Because whatever is the respective x value 1.333 is indeed part of your domain, and therefore you are going to say that equal to sign will come over here. But will the equal to sign come over here for 4? No, because 4 is the output when x was 0 and 0 is not included as a part of the domain. So in this case, this becomes your answer. Now, let's do one question when there is only one factor repeated for 3 times. So the question is, find the range for f of x is equals to x minus 1 the whole cube for, let's choose a domain in a while. So my x-intercept is 1 in this case. What is my y-intercept? My y-intercept is when x is equal to 0. Minus 1 cube is minus 1, so of course minus 1 has to be my y-intercept. And because the x cube is positive, so the graph is going to increase upwards. Overall, my graph should look something like this. My graph should look, see, x cube is like this. So the same kind of graph you will expect, but instead of at origin, it will be shifted to the right side by 1 unit. So yeah, something like this is what I think should be there. Okay, like this. Oops. So over here, let's define some domain. Over here, as we can see that there is nothing such that we can't find directly from the graph. So yes, this kind of graphs will be very popular in terms of range questions if they don't ask you to solve the derivative and then find the maxima or minima. So in this case, let's say that the domain is in between 0, or let's say x greater than 0 only, greater than equal to 0, something like this. So in this case, clearly we can see that x equal to 0 is over here and everything to the right side will be part of the domain. So the graph over here will be part of your entire domain, and the outputs can go up to plus infinity starting all the way from -1. So -1 becomes your minimum value, the maximum value is plus infinity. Okay, so in that case the range will become f of x is always going to give you the outputs that are greater than -1. Because 0 was included as a part of the domain, -1 will be part of the range as well. So here comes our final answer. Comparing this with the Desmos, x minus 1 the whole cube, and the domain is x greater than equal to 0. So yes, this is what we can see. This is what we are getting as well, right? The yellow part. So yeah, the minimum value is -1 and the positive, I mean the maximum value is going up to infinity, as you can see. There is no stop. So yes, this is the correct answer that we have got. I'll just go back to this question. Let's say over here, another domain. I'm just giving another question over here by splitting this. Okay, in the same graph, you can try this. Maybe question is find range for domain. Let me write for in the second line. For x is less than equal to 1 or less than 1. In this case, what part of the graph should be highlighted? So 1 is over here. From this part, you are going everything to the left side. Let me use some different color. I guess almost all the colors I've used. Let me use blue. So from 1, you are going to the left side, everywhere to the left side. So this part of the graph, the one that I've highlighted in the blue, the maximum value it can take is plus infinity in that case, and the minimum value it can take is of course 0. So in this case, the output that you will be getting would be f of x is always greater than 0. It means, is 0 part of the range? No, because x equal to 1 was not part of the domain. So yes, that becomes your final answer, right? Only look at the blue part. Okay, so yeah, you can make sub questions like this and just practice them. That is the kind of an example that I wanted to show you. The yellow part was of course for the first thing that I've drawn, and yeah, if you watched my video you will be able to understand my notes, or else it will be a bit crazy. So yeah, if you're someone who is watching this video, it's good for you that you have looked into this, but just for the sake of notes, I'll just simply delete this part. But I hope that you've got an idea of how you can deal with this kind of things and how you can play around this kind of an idea. And you can repeat the same thing for the square root graphs. Create your own functions. Okay, create random functions. You should be aware about the transformation rules over here, and then try to plot the graph for the domain, and then see what kind of outputs you're getting on the Desmos, and then just see that the range that you got with your own graphs, is it matching on the Desmos? If yes, you are good to go. So I hope that in this video I was able to clear what are the three different types of graphs that you should be aware about, and then if there are any kind of turning points in between, and if the logic is not given to you, what are the coordinates from the previous part, you will always be given some kind of a question through which you can easily find your range just by a rough diagram like what you have drawn over here. Okay, so keep on practicing this kind of questions by yourself. If you are stuck anywhere, feel free to comment it and I'll help you out in the comment itself that this is the function and this was the answer, but I'm not able to get it. So yeah, I can get back to you on the comments and can help you over there itself. Remember that the cubic graphs and the square root graphs are not very frequently asked, but yeah, you should be aware about this kind of a concept being in an AS level curriculum. Okay. The next video that I'll be showing will be the most important, one of the most important in the part of the range, because that is where students stumble upon, where you deal with the reciprocal graphs. Okay. So yeah, I'll see you over there. Thank you so much.